Hi everyone. Today I will explain routing protocols and how they work inside an autonomous system. I will also explain the routing process, convergence, and different routing protocols like routing information protocols, open shortest path first, enhanced interior gateway routing protocol, and border gateway protocol. Routing protocols are very important in networking. Routers use routing protocols to share information with each other. This helps routers learn about distant networks. Without routing protocols, routers will only know the networks directly connected to them. Routing protocols also helps routers choose the best path for sending packets. This makes the network more stable and organized. When a router receives a packet, it follows a routing process. First, it looks for the longest prefix match. This means it looks for the most specific network match in a routing table. If there is more than one match, the router checks administrative distance. And administrative distance shows how trusted the source of the route is. If there is still more than one choice, the router checks the metrics, and the metrics is the cost of the path, and the lowest value wins. The diagram that you've seen shows a simple example. A packet moves from network A to a router. The router checks its routing table and then forward the packets to network B. Routers always move packets hop by hop until they reach the final destination. Let's talk a little bit about convergence. Convergence means that all routers in the network agree on routing information. When convergence is fast, the network works better. When convergence is slow, there can be delay or packet loss. Distance vector protocol usually converge slower. Link state protocol converge faster. Let's talk about autonomous system, which we call AS. Autonomous system, or AS, is a group of routers under one organization or administration. Inside one autonomous system, we use interior routing protocols. Between different autonomous systems, we use exterior routing protocols. Border gateway protocol is used between autonomous systems. This diagram shows two autonomous systems. Each one has its own routers. Border gateway protocols connect them. This allows communication between large networks like companies or internet providers. There are different types of routing protocols. Distance vector protocols send their full routing table to neighbors. They are simple but slower. An example is routing information protocol. Link state protocol build a full map of the network and update only when changes happen. An example is open shortest path first. Link state usually converge faster. Classful protocols do not support variable length subnet masking, also called VLSM. Examples are information protocol and interior gateway routing protocol. Classless protocols support VLSM. Examples are routing information protocol version 2. Enhanced interior gateway routing protocol. Open Shortest Path First, and Border Gateway Protocol. VLSM allows different subnet masks in the same network. Let's look at 6 protocols in detail. First, we will talk about Routing Information Protocol, or RIP. And second, Routing Information Protocol version 2, RIVP. And third, we will look at Interior Gateway Protocol. Interior Gateway Routing Protocol, RGRP. The fourth one is Enhanced Interior Gateway Protocol, EIGRP. And the fifth one, Open Shortest Path First, OSPF. The sixth one we will talk about is Border Gateway Protocol, BGP. Let's start with the first one, RIP. Routing Information Protocol is a distance vector protocol. It uses hop count as its metrics. The path with the lowest hop count is chosen. It is an interior routing protocol. It does not support variable length subnet masking. It also has slower convergence. The second one, which is RIP v2, Routing Information Protocol version 2, is similar to RIP. It also uses hop count. It is also interior. The difference is that it supports variable length subnet masking. However, it still has slower convergence. The third one we will talk about is IGRP. Interior Gateway Routing Protocol is a distance vector protocol created by Cisco. It uses bandwidth and delays as its metrics. It is used inside an autonomous system. It does not support variable length subnet masking. Number 4, which is EIGRP, Enhanced Interior Gateway Routing Protocol, is a hybrid protocol. It combines features of distance vector and link state. It uses bandwidth and delays at its metrics. It supports variable length subnet masking. It converges fast. The best part is called the successor. The backup part is called the feasible successor. And number 5, OSPF, Open Shortest Path First, is a link state protocol. It uses cost based on link speed as its metrics. It is used inside an autonomous system. It supports variable length subnet masking. It's divide network into areas. Area 0 is the backbone area. And last but not the least, which is BGP, Border Gateway Protocol, is a path vector protocol. It is used between autonomous systems. It uses multiple attributes to choose the best path. It supports variable length subnet masking. It is also used on the internet. This table compares all routing protocols. Some are distance vector, some are link state, and one is path vector. Some support variable length, subnet masking, and some do not. Exterior protocols are used inside one autonomous system. Border gateway protocol is used between autonomous systems. Friends, in conclusion, I will quickly summarize what we'll discuss in this PowerPoint. Routing protocols helps routers share information and choose the best path. The routing process uses longest prefix match, administrative distance, and metrics. Interior and exterior routing are different. Each protocol has its own strengths and weaknesses. Understanding this protocol helps us design better networks.